So our second lesson for today, we are going to multiply and divide rational expressions. So we're going to be multiplying and dividing. Rational means fractions. Expression means we're going to have no equal signs. So we're going to have two fractions either being multiplied together or divided. So here's an example of a rational expression. Both of these are actually being multiplied. The one on the left is already factored, so you just have a bunch of sets of parentheses, greatest common factor sitting in front of them. And then what you're going to be given is on the right side that's not factored. So in the case that I would give you something that's already factored, if it's multiplication, you can think of this as just one big old fraction. If you think of that as one big fraction, technically this would need to be in parentheses. And then we can cancel anything that's the same in the numerator and the denominator. Remember, they have to be exactly the same. So what can I cancel? So the x plus 4's cancel. You ready for the trick thing? Here, this x right here, would you agree that that x that I just circled right here is only involved in multiplication? It's being multiplied by the 2 and it's being multiplied by the parentheses. The same thing's true about this x right here. It's being multiplied by the 5 and it's being multiplied by the parentheses. Since it's only involved in multiplication, we can cancel it out. So we can cancel out both those x's, we can cancel out the x plus 4's. That leaves us with 2 times x minus 7 in the numerator. And then the denominator, x minus 3 times x minus 2. Oh, don't forget your 5. So if it's already factored, you're just going to cancel anything that's the same in the numerator and the denominator. If I give you a problem like the one on the right, it's not factored, guess what you get to do? Yep, we get to factor it. So for this problem, we're actually going to use our asterisks 3 times and greatest common factor once. So we have an asterisk here, and greatest common factor there. Whew. A lot of factoring, all for one problem. So for the first fraction, the numerator, when I fill out my asterisks, I'm going to have 1 top left, top right, -2 in the bottom middle, and 1 times -15 in the top middle. Then I'm looking for 2 numbers that multiply to give us -15 and add to give us -2. Those 2 numbers would be -5 and +3. So that numerator of the first fraction simplifies to x minus 5, x plus 3. Then we're going to keep going. I'm going to factor the denominator of that same fraction. 1, 1, 7, and 12 times 1 is 12. So we have 1 in the top left, 1 in the top right, 7 in the bottom middle, 12 in the top middle. We're looking for 2 numbers that multiply to give us 12, but add to give us 7. Excuse me. Those 2 numbers are going to be 4 and 3. 4 times 3 is 12. 4 plus 3 is 12. Is 7. So they multiply to give us 12, add to give us 7. So in my fraction, I'm going to have x plus 4, x plus 3. Again, order doesn't matter as long as you have them both. Moving to the second fraction, in the numerator, we said we need an asterisk, so we're going with 1 in the top left, 1 in the top right, 3 in the bottom middle, and -4 in the top middle. two numbers that multiply to give us -4 and add to give us 3. So hopefully you said those two numbers are +4 and -1. So we have factors x plus 4 times x minus 1. The denominator is different. It's not 3 terms, so we want to look to see if there's a greatest common factor. In this case, there is a greatest common factor because they both have x in them. So we're going to factor an x out. If I factor x out of x squared, I end up with x. If I factor x squared out of -5x, all I have left is just the -5 or the -5. Since this is multiplication, I want to cancel anything that's exactly the same with anything that's exactly the same on the bottom. So anything on the top that's exactly the same as the bottom, I'm going to cancel out. So first thing I notice is this x plus 3 and this x plus 3. One's on top, one's on bottom. Remember, since this is multiplication, we can imagine this is one big happy fraction. So I can cancel anything on either top with either bottom. So I can also go in and cancel this x minus 5 with this x minus 5. Yeah, they were originally on different fractions, but one's in the numerator, one's in the denominator. Same way with the x plus 4 and the x plus 4. So technically that first fraction completely canceled out, leaving me with x minus 1 on the top and x on the bottom. Can I cancel those x's? No, I'm not allowed to cancel them because the one on the top is involved in subtraction, the one in the denominator is not, so they're not exactly the same. Questions on that one? You good? So there's an x minus 5 here and there. So it doesn't matter what fraction you're on as long as one's in the numerator and one's in the denominator. On the next page, we're going to multiply these two fractions together at the top. So looking at those, I have an asterisk problem for the numerator. So for this first problem up here at the top, we're going to use our asterisk. Whoops, not a box. So in our asterisk, we have 2 and 2. 7 in the bottom middle. Be careful with the top middle. You need to multiply 2 times 3 to get 6. So I'm looking for two numbers that multiply to give us 6 and add to give us 7. That would have to be 6 and 1. 2 and 6 reduced to 1 and 3. So that actually factors into x plus 3 times 2x plus 1. Does the denominator of this fraction need factored? Can I do anything with x minus 4? No. I'm just going to leave it as x minus 4. So sometimes you have parts or pieces that do not reduce. So that x minus 4 does not factor, so we can't do anything with it yet. Moving to the second fraction, the numerator, we have x squared minus 16. What kind of factoring do we need to do with that? I didn't hear you. Is there a greatest common factor? Do they have anything in common? No. So they don't have anything in common. It is x squared. Is x squared a perfect square? Yes. Is 16 a perfect square? Is there a minus sign in the middle? So this is a difference of squares. So that's our two sets of parentheses, one plus sign, one minus sign. Again, the sooner we can learn to recognize these, the easier things are going to be for us. Bless you. So x squared minus 16. I'm going to square root x squared to get x first in both sets of parentheses. I'm going to square root 16. Square root of 16 is 4, so 4 goes last in both sets of parentheses. And then for the denominator, x squared plus 8x plus 15, that is a quadratic requiring us to factor using our asterisks. So 1, 1, 8, and 15. So we're looking for two numbers that multiply to give us 15, but add to give us 8. 5 and 3. So that gives us x plus 5 and x plus 3. And again, since this is multiplication, we can think of this as one big old fraction. And now I can go through and cancel anything that's exactly the same on the top of the fraction as it is the bottom. So you tell me, what can we cancel? X plus 3 up here cancels with x plus 3 down here. X minus 4 down here cancels with x minus 4 up here. Can I cancel anything else? No, I'm done. So whatever's left is going to be part of my answer. So 2x plus 1 and x plus 4 end up on top. And then the bottom, we just have x plus 5. And that right there would be our final answer. Questions on that one? So typical problem right there. Factor, 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 cancel as much as possible, write what's left in your fraction, and you're done. Looking at the next question, we're going to multiply these two fractions together. We want to factor, 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 factor. Looking at the numerator of the first fraction, we have a squared minus 4. How in the world are we going to factor that? Absolutely, it's a difference of squares. So two sets of parentheses, one plus sign, one minus sign. The square root of a squared is a, so a goes first in both parentheses. The square root of 4 is 2, so 2 goes second in both parentheses. Looking at the denominator, a squared minus 1. How are we going to factor a squared minus 1? The same thing. It's also a difference of squares, two sets of parentheses, one plus sign, one minus sign. The square root of a squared goes first, so a and a. The square root of 1 is 1, so 1 goes last in both sets of parentheses. That's being multiplied by the second fraction. Can I factor a plus 1? No, we're just going to leave it as a plus 1. If it makes you feel better, put parentheses around it. How am I going to factor a squared plus 2a? Greatest common factor, they both have a's in them. So I'm going to factor out an a, leaving me with a plus 2. Take a minute on your paper, see if you can go through and reduce anything that's the same in the numerator as it is in the denominator. Keep in mind, we're going to think of this as one big happy fraction because they're being multiplied together. Hopefully you wrote your answer as a minus 2 in the numerator, and then a times a minus 1 in the denominator. Final answer. Again, can't cancel the a minus 2 with the a minus 1 because they're not exactly the same. So that's exactly what we're going to do anytime we have a multiplication problem. We're just going to factor, 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 and then cancel. When we divide, so our symbols or our signs right here are changing to division. So right here, we've changed to division. When that happens, we are going to keep, change, flip. Sometimes it's called multiply by the reciprocal. It's just like we used to do with regular fractions. So back in Dusty's class, when you worked on dividing fractions, you keep, change, flip. We're going to do that exact same thing, except we have bigger numbers and variables. So when we keep, change, flip, we're going to keep the first fraction that they're the same. So this fraction's not going to change. But remember how I told you earlier in the term, I'm really lazy. I know at some point I'm going to have to factor this. So when I keep it, I'm going to go ahead and factor that into my 2 sets of parentheses on the top, 2 sets of parentheses on the bottom. So looking at the top, if I would fill out my asterisk, 1, 1, -5, and 6. So 2 numbers that multiply to give me 6, but add to give me -5, -3, and -2. So I have x minus 3 times x minus 2. Again, that's the factored form of the numerator that we were given. We're going to do the same thing for the denominator. In the denominator, we would have 1, 1, -6, and 8. 2 numbers that multiply to give us 8, but add to give us -6, -4, and -2. So x minus 4, x minus 2. So that's our keep. We kept the first fraction exactly the same as it was. We just went ahead and factored it. The change happens when we bring this down. We do not write it as multiplication. We change it to division. So there's our change. This was our keep. And then we're going to flip. What flip means? We're going to take this fraction, we're going to flip it upside down. So the numerator becomes the denominator. So the 1, instead of writing the 1 on top, I'm going to write the 1 on bottom. It doesn't factor, so I'm just going to leave it as 1. Same thing with the p minus 4. I can't factor that, so I'm just going to leave it as, oops, I think I used x's on the other side. X minus 4. So we flipped that second fraction upside down. Now we want to go back and cancel anything that's the same on the numerator and the denominator on either fraction. So the first fraction had x minus 2 on the top and the bottom. There's an x minus 4 on the top and an x minus 4 on the bottom. So really that means all I have left is x minus 3 divided by 1, which you could just write as x minus 3. So very, very similar to what we had been doing, except that keep, change, flip has now been added if we have a division problem. So last question, we're going to, again, have a division problem. So we're going to keep, change, flip. We're going to keep the first fraction the same. N minus 7 does not factor, and neither does the 10, so I'm just copying it back down. The change comes when I have the division sign. I'm changing it to multiplication. Then I'm going to flip the second fraction. When I flip the second fraction, the numerator becomes n plus 6. That does not factor, so I'm going to leave it alone. But when I go to move the numerator to the denominator, I know the n squared plus 4n minus 12 is probably going to factor, so I'm going to factor it before I move it. So in my asterisk, I have 1, 1, 4, and negative 12. Two numbers to multiply to give us negative 12 and add to give us 4. So those two numbers would be 6 and negative 2. So in plus 6, in minus 2. So I factored it when I flipped it. Then I can go ahead again, since this is multiplication now, I can go ahead and cancel anything that's the same in the numerator and the denominator. In this case, just the n plus 6 is canceled. I'm left with n minus 7 in the numerator and 10 times n minus 2 in the denominator. Again, final answer because I cannot cancel those n's out. Questions or concerns?